Hello, hi everyone. Today we will discuss about probability and statistics. And in this course, we will discuss important concept that is random variable and expectations. First, we will discuss what is meant by random variable. Random variable is nothing but it's a variable whose possible values are outcomes of a random phenomenon. In other words, we can say it is a variable that can take on different values based on outcome of a random experiment. This random variable should be discrete or continuous random variable. What is meant by discrete random variable? Discrete random variable can take on a finite or countably infinite number of discrete variables. From this random variable, we will be constructing the probability distributions. That is called the discrete probability distribution, and its distribution functions as called the probability mass functions. These mass functions gives only the probability of each possible value which should be discrete. For example, the number of heads obtained when flipping a coin 3 times. When we flipping 3 times the coin, we could give 8 possible outcomes. That sample space we know. Okay, and so on. Okay, there are so around 8 possible outcomes we will get. That is called the sample space, which will be discrete. The next, another type is continuous random variable. What is the continuous random variable? Continuous random variable is nothing but that the variable x should be uncountable or infinite number of values. You are specified between a range or interval. That is called the continuous random variable. From this continuous random variable, we will be described the distributions. We describe a distribution that is called the continuous probability distribution. And its functions called the probability density functions. For example, the height of a randomly selected persons. Okay, we'll be selecting a persons randomly. The height we have to measure for each person, which should be an interval. For example, first sample will be selected. That first person's height is 150 to 175 centimeter. Then next, what is the expectations? Expectation is nothing. It's the expected value of a random variable, whether it should be discrete or continuous. Okay. And this expected value, that means it represents average or mean value that we would expect to observe over a large number of repetitions of an experiment or random classes. It is called the expected value. The expectation of a random variable is converted by p of x. That means when you knew what is the expected value for that mean value from the random variable x. First, the expectations we could calculate from a discrete as well as the continuous case. The first one, the expectation of a discrete random variable is calculated using this formula, expectation of Px, that is equal to summation of xi into P of capital X equal to small xi. In the sum of the random variable capital X, and thus we are having the sample value small x1, x2, etc. Pxn. And its probability as mentioned here, the P of capital X equal to small xi. In the next here, the xi represents each possible value of a discrete random variable capital X, and P of x is called the probability mass functions of the particular distributions. The next, another case is continuous random variable. How to obtain the expectations of using the continuous random variable? Here we are using the integral x into f of x into x. The previous case, the discrete case, we have used the P of capital X equal to small x. That is a probability mass functions. So here we are using integral x into, that is x, the continuous random variable, into multiplication of the f of x dx denoted by probability density functions of these continuous random variable. Okay, in this one, we had discussed what is that random variable and its a type discrete and continuous, then how to obtain their expected value from a discrete as well as continuous case. The next we'll be discussing probability distributions. Okay, we describe a random variable from discrete as well as continuous. We have described two different distributions. One is a discrete distribution, another one is continuous distributions. Here we will discuss few important discrete probability distributions and one or two important continuous probability distributions. First one, the discrete distributions. First one is the binomial distribution. How we derive binomial distributions when X is a discrete random variable. Describe the number of successes in a fixed number of independent Bernoulli trials and same probability of successes. Example include coin flips and success failure experiment. The binomial distributions having two outcomes. One is success, another one is failure. It would be happen n number of times. N number of times. And then we have derived their binomial distributions probability mass functions. So that is P of X equal to NCX P power X Q power N minus X. In these distributions containing two parameters, one is N and another one is P. Then its mean, the binomial distribution mean is NP and variance is NP. The next, another discrete distributions, that is a Poisson distribution, and its probability mass function is P of X equal to e power minus lambda divided by lambda x, e power minus lambda divided by lambda power h divided by x factorial. Its parameter is lambda. One and only these distributions having mean and variance are same, that is the lambda. The parameter also lambda. Okay. How it will be often used for rare event, such as the number of women received in a hour. The next, another important distribution is the normal distribution or Gaussian distribution. It's called the continuous distribution. Okay, this is a very, very important distributions. It has some characteristics, that is the bell-shaped curve symmetric around the main, and many natural phenomena follow this distribution, such as tides and waves of the people. It's having